Hello everyone. Now today we're going to discuss about for singularity of a complex function. Now first we need to look at the definition of a singular point. Okay. Now with some point of the z where f of z is not analytic. Okay. Now at that point is a singular point. Some region that f of z some z equal to, let's say, z naught. At this point f of z is not analytic, nothing but not differentiable at this point. Okay, if not differentiable, now that point is known as a singular point of f of z. Okay, now for these at that f of z point, for that z point, for f of z have the expansion. Okay, now we can able to expand it as a sum powers of z minus z naught. Okay, based on that we have the four types of the singularity for the powers of z minus z naught. That singularities are isolated singularity, removal singularity, essential singularity, and pole singularity. Okay, at z equal to z naught, it should be expanded Lorentz series expansion. Based on the powers, we can categorize the four types, right? First one isolated, second one removal, third one essential, and fourth one pole singularity. I think well known the Lorentz series expansion. Once I remember it, then what is the expansion of Lorentz series? Okay, now look at the expansion of Lorentz series. For z equal to a here, I take for a z equal to a is a singular point. At that point we can expand it expansion for Lorentz series for f of z. It should be have positive powers and negative powers of z minus z. Okay, now positive powers quotient is an, now negative power z minus a is bn. Okay, now this expansion is Lorentz series expansion. Okay, based on the powers we need categorize into the four parts. Okay, four types. Now first one, isolated singularity. Now listen carefully. At z equal to z naught be a singular point of f of z. The Lorentz series expansion of f of z at z equal to z naught having infinite number of positive powers and infinite number of negative powers of z minus z naught, then that singularity is known as isolated singularity. Okay, if I want to expand this f of z in terms of z minus z naught, then that expansion having for infinite number of positive and infinite number of negative is isolated singularity. Nothing but general Lorentz series expansion infinite having for positive and negative. Now next, removal singularity. For this removal singularity, now for the Lorentz series expansion of f of z at z equal to z naught is a singular point. At z equal to z naught should be having the power z minus z naught having only positive powers or simply vanishing the negative powers of f of z minus z naught. Vanishing the negative powers of z minus z naught is known as removal singularity. Easy to remember for the removal. We can remove the negative powers. Okay, having only positive powers of z minus z naught. Like that also you can remember it for removal singularity. Next, third one, essential singularity. In this essential singularity at z equal to z naught, for Lorentz series expansion f of z having infinite number of negative powers and finite number of positive powers. Infinite number of negative powers of z minus z naught, finite number of positive powers of z minus z naught is known as essential singularity. Next, pole singularity. Now at the z equals z naught is a singular point for the Lorentz series expansion of f of z having now infinite number of positive powers and finite number of negative powers of z minus z naught. Simply opposite of this number here. Infinite number of negative, infinite number of positive. Finite number of positive, finite number of negative. Okay. Now this is pole singularity. Okay. Now next, if this pole singularity, the expansion for f of z having some m powers of z minus z naught, then that is known as pole of order m. Okay. after m power there is no negative power. Okay, they're having finite number of negative, that negative powers of m terms, then pole of order m. Okay, if m equal to, if m equal to for example 4 is pole of order 4. If m equal to 10, 10 negative powers we have, nothing but z minus 1 by z minus z naught whole power 10 power should be appearing, therefore is pole of order 10. Now like that we can have it for how many negative powers we have, that we have pole of order. Okay, m power m terms pole of order m. Now if m equal to 1 is pole of order 1, nothing but we have the special name that we have simple pole. Okay, now these are the definitions for types of the singularity. Now look at the problem. Find the nature and location of a singularity of a following functions. First one, f of z equal to z minus sin z by z square. Now we need to find out the singular point first, where it is not analytic. That when you look at the denominator for z square, when put for z equal to 0 is something by 0, nothing but is turning to infinity. At that point z equals 0, the function not able to derive it, therefore the z equals 0 is singular point. Okay, now we need to have the expansion of z minus 0 powers. Okay, z minus 0 powers nothing but z powers. Okay, now we try to convert as a z powers here, z 1 by z square into z minus sin z expansion, sin z expansion. Now sin z we are having odd powers, right? Z cube, z power 5, z power 7. Okay, now cos we have 1 minus z square by 2 factorial plus z power 4 by 4 factorial minus z power 6 by 6 factorial plus and so on. The exponential function we are having all positive and negative together, right? Now that I will go into expand here, sin z expansion here. Okay, now 1 by z square multiply with each term. Now z by z square plus into minus is minus, z by z square plus minus into minus plus, z cube with 3 factorial into 1 by z square. Okay, here 2z cancel, 1z remaining, 1 by z square multiplier plus into minus is minus, z power 5 by 5 factorial, that into z square. Okay, z square cancel here, remaining 3 powers, like that we saw. And then simplify, these are same terms with having different sign, plus minus will cancel. Now remaining write it here is z power 1 by 3 factorial minus z cube by 5 factorial plus z power 5 by 7 factorial plus and so on. Now f of z expansion having only positive power, there is no negative power. Okay, there is no negative power, negative powers are vanishing, therefore the z equals 0 is a removal singularity, is a removal singularity. Okay, now look at the second one, z plus 1 into sine 1 by z minus 2. Now when z equal to 2 here, now it tends to 0, 1 by 0 is infinity. At that point we can't able to find the derivative, therefore z equal to is a singular point. For total function we try to convert as z minus 2 powers. To get that I simply let for t equal to z minus 2, nothing but we try to get this now in terms of t, where you have to simply substitute for z minus 2, then simply to have for z minus 2 powers. Okay, now substitute for t equals z minus 2 and z equal t plus 2. Now substitute z equal t plus 2. Now t plus 2 plus 1 is t plus 3 sine 1 by z minus 2. Z minus 2 is t. Now again apply the sine z expansion here, sin x expansion here. Okay, now simply multiply with this total bracket into t plus 3 into total bracket. Then we have t into total bracket plus 3 t into total bracket plus 3 into total bracket. So simplify this, having here one constant term having t power 0. Okay, simply t power 0. Now 3 by t, here t square term, t cubed 1 by t cube, 1 by t power 4, 1 by t power 5, right? That term I write it here. Now what is the t value? Z minus 2. Okay, previously we let it here, z equal to t minus 2, that I substituted here. Okay, now you are having here negative infinite number of negative powers. One we have here 0 power, therefore z equal to is a essential singularity. Okay. Now third one, f of z equal to e power 2z by z minus 1 whole power 4. When z equal to 1, simply is 0. Something by 0 is infinite. Now at that point we can't able to find the derivative, therefore z equal to 1 is a singular point. Okay. Now try to convert this total function in terms of z minus 1 powers. That's why let for z equal to t equal to z minus 1. Now z we have t plus 1. Now this z equal to t plus 1 substitute here. Now e power 2t plus e power 2t plus 2, that can be e power 2 into e power 2t, right? Now by t power 4, e power 2 by t power 4. Now e power x expansion I will use it. E power x expansion is 1 plus x square by 2 factorial plus x cube by 3 factorial plus x power 4 by 4 factorial. That we have to apply it. In place of x we are 2t apply it. Okay. Now multiply with e power 2 by t power 4 each term. Then we have here e power 2 by t power 4. Then some t power cancel here, right? When you multiply t power 4, t cancel, we have 1 by t cube, t square cancel here, 1 by t square, t cube cancel, we have 1 by t power 4 cancel, we have constant term we occur. Next term t power 5. Now t power 4 cancel, we have t term, right? Now this we have t power 4, t cube, t square, t, some constant term, t term, next t square, t cube, and so on. Now what is the t value here? T value is z minus 1. Okay, z minus 1 substituted here. Now here finite number of negative powers of z minus 1, infinite number of positive powers of z minus 1. Therefore z equal to 1 is a pole singularity, right? Now what is a pole of order? Pole of order, what is the highest power of negative is 4, simply pole of order 4. Okay, now last one, f of z equal to 1 by z into z 2 minus z, z equal to 0 and z equal to 2 is a singular point. The simply I give an answer here is a simple pole of f of z. Now try to convert as a z powers here, it should be have 1 by z term. You try to convert for 1 by 2 minus z powers, the simply we have 1 by 2 minus z, we have only one power, that's why z equals 0, z equal to is a simple poles. Okay, only pole of order 1, simple pole of f of z. Now this you have to try it to get a expansion polar Rn series, simply to offer 1 by z and 1 by 2 minus z powers. Okay, this is a way to find out the singularity of the different functions. Thank you.